Today we will talk about automated testing in Magento 2. My name is Igor Miniailo and I'm Magento architect. I'm known in Magento community that I always add a photo of myself into my slides. Let's start from the beginning, because in Magento, based on your experience, and I believe most of people here have experience working with Magento 1, and in Magento 1 there was a slight problem with the absence of documentation, or that documentation was not accurate or it was outdated. That's why we used to find another sources of documentation. That's why actually the Stack Exchange gets so many popularity among the Magento community. And things changed drastically since Magento 2 invest a lot of time into the documentation. But still people from Magento community sometimes look for alternative sources of documentation. So I really recommend you, if you stuck with any issue or you need to get into some new functionality which is supported by Magento, which is implemented by Magento, to have a good habit, start your journey with this feature from the Magento documentation, because we really invest a lot of time into documentation. And our dev docs get better and better. And for this particular subject I am going to highlight today, there is a dedicated chapter, which the name of the chapter is Magento Testing Guide. So from this guide you will get an idea how to run different kind of testing, integrational, static, or functional, and you will see how to fix if you have any issue with them. Okay, so today, as I said, we will talk about Magento 2 and automated testing in Magento 2. And actually, the examples which I will provide you would be based on a multi-source inventory project. And if you have a question, why actually the MSI was chosen as a source of answering your question? So actually, the answer for that question was already given today. So here's the answer. And that was not my statement. So the MSI currently is a really good example for a reference of good practices, how to write correctly different stuff, not just the multi-sourcing, like how to work with the resource models, how to build the interfaces, how to work with the UI components, etc., etc. So refer to this project just to see how guys from Magento work and how really smart guys from community contribute to Magento. So actually MSI, maybe the name of the project is a little bit misleading because the abbreviation states for multi-source inventory, but actually MSI is totally new inventory. It's the inventory which comes and supposed to substitute the existing catalog inventory we have, and the catalog inventory we have currently has flaws, has drawbacks, and we're supposed to fill these gaps. And one of the basic feature, which is currently absent at all, would be split the inventory between different sources under the hood of one Magento installation. So this is precisely what we call multi-source inventory. So let's get back to testing, because actually the name of the talk is testing. So let's get to testing, and let's start from the pyramid testing. And actually, pyramid, if you'll build the pyramid of testing for your particular project, because for each of the project it's gonna be different, because it's based on your test coverage you have currently. So, but ideally, one of the famous guy you probably know, so it's famous blogger, actually characterize the testing pyramid this way, because you're supposed to have a lot of quick tests, which are easily to write, which are really fast to run. After that, you have tested for your services, and after that, on top, you have UI tests or a functional test. So there was a big article of Martin Fowler about this, and there were a lot of discussion with the Ken Beck, etc., and all other very well-known developers and architects. So let's see how this pyramid looks like for Magento 2. So in Magento 2, so this is actually, the diagram represents the ratio of different kind of tests we have in Magento. So currently we have like quite a lot of, it's more or less similar and represent the pyramid which was described by Martin Fowler in his article. So we have quite a lot of unit tests because for a long time in Magento 2 we had a requirement, so we have a definition of done, and all the newly created code supposed to satisfy these requirements. And we have a definition of done which stated, I use the past, that all the newly created functionality is supposed to be covered with unit tests. I will describe why actually it was in past and why don't we have this requirement anymore. So after that, you see that we have quite a lot of integrational testing, and currently in this time we see that the code base of integrational tests growing rapidly. So actually this part of the segment is a growing part now. So after that we have the web API, so tests which cover our API accessible through SOAP and REST, and soon we will test covering the GraphQL, which will get to this layer of the pyramid, and after that the functional tests. So let's start from the bottom to the top, and let's start talking about unit testing. So when we are talking about the theory of unit testing, actually in his article, Martin Fowler differentiated two types of possibilities how you can write unit tests, whether this test is going to be sociable or whether it's going to be solitary. So actually the main difference here, how the test works with the collaborators. Actually, by collaborators we mean all the external dependencies and all the external functionality which are needed to our particular class or unit which we test. So you probably know that Magento 2 supports the constructor dependency injection, and what it means. That means that after the product is instantiated, we already have all the external dependencies needed for all possible operation on all the possible operation for this particular entity. And that's why it was decided that in Magento we will use the solitary tests. And currently in our unit test approach, all the external dependencies are mocked and injected to the object under the test. When we say that the real dependencies are substituted with something, so the real collaborators are substituted with something, we're actually talking about test doubles. There are, again, in a test theory, there's a lot of different test doubles, but actually in PHP unit, there are just two types of them. There are mocks and stubs. Of course, you can implement like a dummy object, but in PHP world, it's not really popular. Like for example, in Java, because in Java, it's pretty common pattern to use a null object. We don't use it. Probably I never seen even in Magento usages of a null object. But this is actually different types of doubles. Currently, we are talking mostly about stubs and mocks. So there was a lot of theory. Now let's dive into code. So let's discover this small piece of functionality. It's our source repository. Source is entity representing the warehouse, for example, in new inventory. And we have just a save. And what the save method does, it just proxies the persistence to particular command. So we have like a low-level service, which the main responsibility of which is just to make a persistent of the source which is passed as a parameter. And how the solitary unit test will look like, written in PHP unit. So here we need to make some kind of initialization in the setup. We create the repository repository object, because repository is the object under the test. We provide all the mocks here as input parameters, and for command, because we are testing save operation, and save actually proceed with persistent. So we pre-create particular mock, and we apply some some checks to this object. For example, we say that the method execute supposed to be called just once with the given source parameter as input, and and this method supposed to return the source ID. And after that we call, and we have the assertion that the output of the service is the same what we expect. So if you consider this particular unit test, we would see that this unit test actually duplicates the behavior we have in the implementation. So it's written like the same logic, but in different words. So we can consider that this kind of unit test is, I will show you. This unit test violates the encapsulation of the method. Because let's consider, this was really really simple example when we have just a proxy, but let's consider a little bit more complicated example. Yesterday we had a contribution day, and during that contribution day, actually the contribution day was mostly devoted for multi-source inventory, and there was different tasks for multi-source inventory being provided, and one of the contributor, Felix, was taking a task, and he was working on a service which is supposed to make a migration from the single stock to multi-sourcing. So supposed to simplify the onboarding and migration process for merchant. So what he did. So here's Felix. So you will see him shortly on the next talk after mine. So what he actually did, and this is absolutely correctly from the solitary unit test standpoint. So he wrote a test. I actually don't show the example of the test. I don't show the code of this test. I will just show you how the unit test look like. And to cover this service with the unit test, he had to provide all the mocking for all the collaborators, for all the external dependency of this particular service. And you will see how he managed to do this. Actually, he wrote the unit test pretty reusable, so he introduced many procedures, because if everything would be put into one method, that method would be pretty long. And looking at this method, you would not, from the first glance, understand what's actually happening here, because we spent too many lines of code, and we spent too many code for preparation all the external dependencies. So it's really easy to be distracted what's actually happening in this test, because the business logic is pretty easy. We need to call the service, pass the SQ, and say that this SQ is supposed to be migrated to this source. But it's not so easy to understand what's happening here. And that's not a problem with Felix and his code. This is actually just a solitary unit test. And there is actually a name for this kind of testing. It's called tautological test-driven development. When we have the needless, redundant repetition of what we already have in our business logic. And as a side effect of this test, we actually, our unit tests currently don't check that business logic works correctly, but actually check that business logic is worked the same way it is written. So it's totally different cases, whether it works as expected and whether it works as it's written. And we have actually really strong coupling between our testing code and between our production code. So again, I'm referring to Martin Fowler here, who considers tautological driven development is a very dangerous stuff, and that's why he really recommends not to use a lot of stubbing and mocking in your testing. And actually, here you see the characteristic of the tautological driven development. I would not say all the items here, but the most important one, of course, at the bottom. So these tests actually don't help you to find bugs in your code. So you spend a lot of time writing this kind of test, but actually these tests don't help you to find bugs. Why? Because the problem not in your unit test. The problem is in transient state, which happens between your object. So if you are working, if you have experience working with Magento 1, you probably know the most usable way of extension in Magento 1. When somebody created the select object, and after that throw the event and put this select object into parameter of this event, and all the observers who track this event just added the left join to particular select, and as a result, when we proceeded with execution of the final SQL query, we were given additional data. So that was pretty typical way how the select object was customized and how the additional behavior been added by third-party modules. But actually, you can never unit test this behavior, because actually you can unit test your particular select, you can unit test your object, but actually the issue happens just in integration when one join joins the initial select. And I will just show you several issues in real life, just to make sure that you understand that unit testing is not enough and you need to make the integrational testing. So this one, and even this one. So all of this, like, it was unit tested correctly, but there is no integration between the entities. And whether unit tests are useless, you will ask me. Of course, no, because if you use unit test correctly, unit test, first of all, that would be the first smell in your code that something going wrong in your business logic, and you would never achieve the test-driven development. You can't practice test-driven development if you don't use unit testing. So if you don't believe me, ask Vinay. He's practicing test-driven development and he's using unit test, and that's really useful. So let's now consider the qualities of test. So the main qualities are readability, stability, and speed. So regarding the readability, let's consider whether our solitary unit test satisfies these qualities. Whether they satisfy the readability qualities. Probably no, because when we consider it a little bit more complicated example of service, which was written by Felix, it was not so easy for us to define the business idea of service and what actually been tested and what's the responsibility of the test. Whether it's easy to support and maintain this test? Of course, no. And another thing that these tests are really fragile. Even if you change the implementation of your service, you need to modify your test. Even if the contract has not changed, so for the same set of input values, you're providing the same set of output values. This is supposed to be important in your code, but you still have the unit test failed because probably number of expects or number of amount internal calls to collaborators been changed, and that's the reason why you have the red test. So current solitary unit tests don't satisfy most of the items here. That's why we come to the integration test. So let's see whether integration test is a good idea to use and whether they provide an answer for this requirement for stability, readability, and speed. But actually, what's the good point of unit test? The speed. Because currently the whole code base of our unit test, the whole test suite can run less than in 3 minutes. So this is definitely a rabbit and not a turtle. So just to provide you, just to give you a small example, and I would just want to give you an example of business functionality which we would like to cover with the integration test. And that business functionality is supposed to be a reservation mechanism we introduce in the scope of new inventory. So actually the brand new entity we are introducing is the reservation mechanism. So reservation is supposed to be created at the time when order placed, and the reservation is gonna be used to adjust the product quantity, because we don't make any source deduction at the time of order placement, but we just create a reservation. I will just give you some example of how this mechanism works. But idea here is that we don't make any very transactional updates. We don't have really sophisticated source deduction. All we do is just append only operation, which potentially could be put into Redis, and that's really high performant. So, like, for example, you have two different warehouses in France and Italy with different stock. This warehouse is combined into index, into European stock, and this is actually the aggregated quantity of 15. We don't have reservation yet. After that, customer comes to our site and places an order and buys 5 products. So at this time, we check whether we can fulfill that order. We check that 15 is more than 5. And we are not making source or stock deduction here, because actually at this point of time, we don't know, we don't have a clue from which source we will make a shipment. So which source would be used to the order fulfillment. That's actually why we postpone this decision till the shipment operation. And what we do is just place a reservation with -5. And our saleable quantity. So in new inventory, we don't have any more inventory objects, which is a part of product entity. We have dedicated service, and we consider that amount of products you have in salability actually is always dynamic operation, and we always make a dynamic calculation, but this dynamic calculation are very fast. So what's the saleable quantity after the first order placement? The saleable quantity in our case is the data we have in index, so 15 plus -5, so it's a result in 10. So this is actually approach, and this is a pretty sophisticated design approach, which is called event sourcing in CQRS, but we implemented it pretty elegant, and it would not bother you with over complexity, because you are not supposed to, because you are supposed to use just an API and not supposed to fix all the internals. So, for example, after the order placement, the customer decided to change his mind, make a reorder, and now he needs just 2 products. And still, because we don't know from which source we will make a shipment, we can make the operation just on a reservation level. So return to stock would be just a reservation with +3. So now we have the saleable quantity 13, because we have 15 plus -5 plus 3, which give us a result 13. Now admin goes to, for example, to admin, and now he actually, so we already placed an order. So what actually the main goal of not actually even e-commerce, but actually all businesses, to take money from customer quickly. And Magento with MSI will provide you this possibility. So we already take money, and now we have a time to process this order, to make a decision from which sources we need to make a fulfillment, because it could depend. It will definitely influence how much money we'll spend for the delivery. So admin runs the source selection algorithm. We make a decision from which sources we will make a fulfillment, create a shipment. At the time of shipment, we decided that we will make a delivery from France. It's strange because we're in Italy, but okay. So we decided that we will make a delivery from France, updated the quantity there. We recalculated the index, so we recalculated index for European stock, and to be more precise, because we still have gap in a reservation, we need to create a compensational reservation. So after this operation, we actually have next saleable quantity, 13, because we have the recalculated value, plus -5, plus 3, plus 2. So this altogether give us 0. So reservation don't influence use stock anymore. And after that, we are just cleaning all unneeded reservation. And this process actually also happens in a dedicated process, in a cron job, for example, not to prevent overcomplication and additional time spent by merchant in admin panel. And this is actually the final state. So we see that our inventory from what we used to see and what we usually see as developers, because as developers we used to think like immediate consistency. We used to think about the transaction we have on the level of MySQL operation. We used to think that if we sell something, that product is just disappear. That's actually how it was implemented in Magento for many years, because when the order is placed, all we've done is just made a deduction on the source stock item. So that actually makes the product just disappear. But in real businesses, we don't have immediate consistency. Almost always we have eventual consistency. And actually this is how things happens now. So we have the eventual consistent system. So that's probably not so easy, like, yeah? So a lot of patterns, event sourcing, CQRS, eventual consistency. But now let's look how the integration test will look like to test this functionality. And you will believe me, I bet you will believe me, that this test is really easily to read and easily to maintain, and it's sexy. So let's see the interface we are going to test. So the main interface we are going to test here is product saleable. So the service which is responsible to say whether a product is saleable or not. And here we have the integration test. You can pay attention here on data fixture. So the data fixture, their responsibility is to pre-create some state. So they're responsible for the preparation of environment, because to place the reservation, we initially need to create some products. We need to create some warehouses. We need to create some aggregated stocks. After that, we need to assign some warehouses to the aggregated stocks. In our case, European stock and the warehouses in France and Italy. And we're supposed to specify how many items of particular products we have on each warehouse. And after that, we need to run a reindex to build a table, because we have the virtual table, so virtual indexes for each of the stock. And now here's the business logic of test. So in business logic of test, what we do, we just check that initial value of product we currently have in stock. So we specify particular SKU, which is SKU1, on stock 10. So stock 10 is our European stock, is 8.5. After that, we place several reservations here, which supposed to subtract -5 items, and after that, get back 1.5 items. And now we check whether our saleable quantity been aligned and whether it's equal to what we expect to see, like 5 items. That's all. So that was I was probably spent 5 or 7 minutes describing the reservation mechanism, but here you see how it works, like literally 5 line items of the business logic. And here, what's the main difference of integration test and unit test? Integration test looks like your business logic. Unit test looks like preparation, initial call. So it distracts you from where is the business logic and what actually happening. Here there is no any distraction. You see like a business logic and how it works. This is actually how the fixture looks like. So here we have a preparation. Here we create particular sources. So here we create source for source for you, yes, etc. And here we specify quantity. So this is the listings of the fixture which was declared in this test. So pretty easily. Also, our integration framework is pretty sophisticated one because it provides own API. Because actually, what it is, Magento integration framework. Magento integration framework install real Magento and apply all the services you call on a real Magento installation. That's why it's really important to clean the environment after your test, because it could happen that one of the tests spoils the environment, and another test rely on clean environment, but actually they get side effects after other tests. That's why they fail. And sometimes it's really hard to find the reason, because your test is correct, your test is green in isolation, but when you run the whole test, you are getting the red test. That's why we in our integration test we introduce the test annotation, and test annotation could be used like as a PHP docs right about the test. For example, here we say that app isolation enable, so we will clean up all the session data. For example, we have DB isolation. So DB, what does it mean, DB isolation? So when you use DB isolation, Magento integration framework wrap with transaction your testing method. That's why you can, for example, change some data in the database, but as soon as it's wrapped into the transaction, after the test execution, transaction would be rolled back and you will get the clean state back. But sometimes, yeah, so it's pretty important to clean after yourself. But sometimes it happens that if you have DDL operation in your integration test, so if you have MySQL DDL operation, so data definition language, if you create tables, if you alter tables, or something like that, for example, we do it in MSI, because we create tables for our indexes. Actually, this is another really interesting feature we introduced. So we introduce multi-dimensional index, and for each stock index, we have own table. And this table created automatically. So this is actually this is break the transaction. That's why we provide another, on the level of the framework, we provide another functionality with a rollback. So rollback is a feature which would be called after your feature, after your test finished. So you would have an ability to clean after yourself in a dedicated place. So this is cleaning state in a teardown method, and actually this is cleaning state in a rollback feature when we need to remove some items. So here let's get back to the qualities of test, and we see that current integration testing in their current state actually satisfy most of the, even all of the qualities we currently have for readability and stability, but actually the you should always pay something for goodness you get with readability and stability, and actually you pay with the speed. Because we need to install Magento, and the integration tests are much slower than unit tests, and actually what we do, we scale them on several agents, because the whole integration test used on one agent will run about 1 hour and a half. So web API testing. So you know that Magento used in integration with other components and with other systems. Some guys who don't like UI components, for example, can use anything. For example, even Drupal, and just integrate with Magento by means of web API. And this is actually was the idea of the service layer we introduced in Magento 2. And actually this is the service, how the service layer looks like. Actually, I steal this slide from Ricardo's presentation in London. But actually, this is the pretty typical stuff how Magento is used with integration, when you can segregate a front end out of the Magento server side. You used to see our RESTful APIs when you have a declaration, and actually declaration make a mapping of REST queries to a particular interface we have as a part of our service layer. So here you see the interfaces for stock management, for stock creation, for getting list of stock, and for persistent stock. And as a part of Magento 2, we added Swagger. And actually Swagger is something similar to what we have in a SOAP, like VSDL. But here we have the JSON schema. And what's the goodness of Swagger? Swagger can build you documentation based on your current installation, because this is documentation which generated by your request. So it could not be outdated because it's generated based on your Magento installation. And this is actually how the Web API test looks like. We have a lot of Web API tests for MSI, and here you, for example, see the test which creates the stock, and it does it via two adapters, via REST and via SOAP adapter. And now a little bit. So we went up to the top of the pyramid, but now let's spend some time about the static testing, because static testing is a really powerful mechanism in Magento, and you know, and we already, it is currently a buzz in Magento community that we switch to strict type hinting, and it was a big deal for us. We considered whether we need or not to shift to the strict type hinting. Currently, strict type hinting considered like a mandatory for all the newly created code since Magento 2.3, and strict type hinting. For us, when we, and actually in MSI we were early adopters of the type hinting because we already have the type hinting, strict type hinting, I believe for like a half of a year, and everything started from this tweet when we decided to ask community whether we need support strict type hinting or not. We get the strong opinion that we need to support strict type hinting, and we wanted a way to check that all the newly created code, because you know on MSI there are a lot of people from community who making contribution, and not all of them are aware about all our requirements. That's why all our requirements supposed to be specified in code and supposed to be tested by code. That's why we created live code testing, strict type check, and currently this strict type check, which applies on all the pull requests. So it checks the diff, so what files are beyond delivered to mainline, and we make this code sniffer check to see whether all the newly created file, and we check just a newly created file because we don't have a mandatory requirement that we need to apply the strict type checking for legacy code, because it could be not backward compatible, or it could require a lot of refactoring. But all the newly created code, so newly created files, supposed to have strict type checking in the header. Also, like currently we are preparing for regression, and that's why we are not allowed to introduce new changes to Magento core code, and that's why we introduce the live code test, which also apply on all the changes file which is going to be pushed, and we now allow the contribution just to MSI modulus and not allow the contribution to Magento core. So all the Magento core changes supposed to be delivered as a separate pull request to Magento core, and after that it's supposed to merge back to MSI, and the MSI pull request supposed to affect only MSI modulus. Actually, it's not so a few modules. Currently, we have 21 modules with the multi-source inventory functionality. But this kind of limitation could be easily added and checked with the live code test, with the static testing, or with other testing mechanism provided by Magento. Functional test. Probably you know that in Magento recently we introduced new functional framework. We call it MFTF, and this is functional framework based on conception with the sexy fancy XML configuration. And now the functional test looks like this one, so it's fully declarative, and under the hood it could generate the conception code. So this is pure declarative approach, and there is no imperative approach anymore in our MFTF tests. Now we encourage people to start contributing and start covering our existing functionality with MFTF test. So feel free to join. We have a dedicated track supported by community engineering team, and we have dedicated guys from core who make advices, who describe how to do it. And of course, they describe how to do it based on multi-source inventory project we are working on. And the last but not the least, just to give you like slight advice, if you are like a part of big project, for example, the size of project like Magento, and you want to start test coverage because you don't have anything covered at that moment, and you don't know from what to start. So because if you have thousands of files with code, and you don't know what's better to start, because you can apply your test for code which is just easily to cover this test, but actually you would not be given the output of this. So you need to introduce some kind of metrics, and this metrics could be here's really good example of metrics, and we use it metrics in Magento for some time. So we use the complexity and the amount of commits per each file. So we calculate the amount of commits which happen to each file, and also we calculate the complexity. So you can calculate some, you can choose some sophisticated mechanism to build like NPath complexity or maybe cyclomatic complexity, but you can use the simple one. You can just use the line of codes, for example, and consider that if you have a lot of lines of code, that complexity of that class probably pretty high. And you can just build the graphic and see what files are changed frequently and has a big complexity. So this particular file is supposed to be covered with test first of all, because probably you have some bugs in that files. And because the code is not so easy, it's not so clear, people make some quick fixes, and making that quick fixes, they break already existing functionality. So use your metrics, which will define you what need to be covered, and after that choose the correct testing strategy, and have a green build, guys.